All right, we are going to do section 10.1 and 10.2, which is organizing and displaying data. As you can see here, we're going to start by looking at bar graphs. Bars are categories, not number values. The category is separate. So you see here how the bread is a completely separate entity than the ham. And there's also a space in between the two bars. The scale measures each value. And the bar graph may have single or multiple bars in each category. So over here we have two things we're comparing, football and basketball, for each individual year. So the year 2000 and the year 2001, and there's this space. So that's a bar graph. Line graphs, which you should be pretty familiar with, you're going to plot your points, and as long as the middle stuff works, you're going to connect the points just like this, so it's continuous. If for some reason the middle numbers don't work, like how many buses you need, you can't have half a bus, so that's when it would be discrete, where you don't connect the points. And again, you can have two line graphs on one, like you're seeing here, but you need to always make sure you have a key. Circle graphs divide a whole piece into portions. So if we add all of these cups up, we have a half a cup, 1 cup, 2 cups, 2 cups, and 2.5 cups. That would be 8 cups total. So 8 cups is our whole, is our 100%. If we want to figure out each of the degrees in these sections, we would have to divide what we're given by the total 8 cups. So if we look at bananas first, we have 2 cups. So 2 cups divided by 8 cups is a quarter of a cup. Now, a quarter of 100% is 0.25. If you divide 1 divided by 4, you get 0.25. So 25% is this section right here. The strawberry is the same exact thing, so we can go ahead and put a 25% there as well. Cantaloupe is 2.5 cups. I guess I'll go back to blueberry. Blueberry is 1 cup. So 1 over 8, if you put that in your calculator, you get 0.125. So that is 12.5%. So right here, 12.5%. Cantaloupe is 2.5. So 2.5 divided by 8. 2.5 is really 5 halves. And instead of writing divide by 8 that way, we could do 5 halves divide by 8. And whenever you're multiplying by, or dividing by a fraction, you multiply by the reciprocal. So this is really 5 over 16. If you divide that out, you get 0.3125. So this section right here is 31.25%. And that looks like it makes good sense. I'll put this in blue so you can see it. And the kiwi is a half over 8. And we'll do the exact same thing. That's 1/2 divided by 8, which is 1/2 times 1/8, which is 1/16. 1 divided by 16 is 0.0625. So this section is 6.25%. The angles are a little different. I continue thinking about that. 0.25 times 360 degrees is 90. So we know both of these are 90-degree angles. If we do 0.3125 times 360, we get 112.5. So this angle right here is 112.5 degrees. Measure that from the middle with a protractor and draw that accurately. 360 times the 0.0625 is 2.25 degrees. So this angle right here is 2.25 degrees. And then last, 0.125 times 360 is 45. So this angle right here, which you really can't read that either, 45 degrees. So, a lot of data in a circle graph. So when you're choosing the appropriate graph, if you want to compare different categories, you're most likely going to do a bar graph. If you want to compare parts of a common whole, that's going to be your pie or your circle graph. And if you want to show change over time, that's going to be your linear situation. Moving right along to the second section. Frequency and histograms. So we're going to start off with a stem and leaf plot. For the leaf has to be 1 digit. So the key is very important. Here it looks like our smallest number is 29 and our biggest number is in the 60s. So our stem is going to be 2, 3, 4, 5, and 6. And then this is a rough one, so I can literally just go in order. So I'm going to throw my 5 for 45, my 4 for 64, 2 for 52. I don't want to miss anything. 53, 52 again, 29, 30, 59, 35, 56, 60, and 55. Now, it's very vital to have this in order and to have a key because we have no clue what this means. So 2, 9, and I'm going to make a key right now so I don't forget. You can use any number, is 29. Is this story about anything? No. Okay. 3 is 0 first and then a 5. And I want to make my numbers the same size also so that it's kind of like lining up right here. 4 is 5 and 7. If we need to put these in order, so we have 2 2s, a 3, a 5, a 6, and a 9. And then for my 6, I have a 0 and 2 4s. If you take this and you turn it sideways, so if you're looking at this as the base, we now have a bar graph where this is 3 bars deep, this one is 6, this is 2, 2, and 1. So that's kind of the nice thing that a stem and leaf quickly enables us to do. And all of these are different keys. That's why the key is so important. So 42 could be your stem, and that would mean 421. It could also mean 4.21. So that's why you really need to explain what each number means. We also have something called a back-to-back stem and leaf. This is if you have like 2 things you're comparing. So we have Marty on this side, Bill on this side, and as you can see, our key still has the normal stem and leaf as well as the reverse stem and leaf. So 14.3 is this right here, and it still means 143 from Marty. Frequency tables means how often something occurs. So in this set of data, there are 3 scores between 68 and 70. That's right here, 68, and then there should be 2 70s. Those 3 scores are accounted for right there. If we look at the 4 scores between 71 and 73, we have 1 of them, 2 of them, 3 of them, 4 of them. So frequency is how many how often something occurs. Histogram is a bar graph that touches, and these are numbers. This is the way the book shows it. This, I believe, is a better way to show it. So this tells you that this section is from 68 to 70. 71 starts the yellow. So this section in the yellow is from 71 to 73. 74 starts the green. So if we want to make our own histogram, we have to think about the range of numbers that we want to put together. So if this is our data of her last 15 vacations, how many days? Since we have 4 sections here, and we're going from 4 to 15, why don't we do 3 numbers in each section? So this section is 4 to 6. This section is 7 to 9. This section is 10 to 12. And this section is 13 to 15. So how many 4 to 6s do we have? There'd be 1, 2, 3, 4, 5 of them. 7 to 9, 1, 2, 3, 4. 10 to 12, 1, 2, 3, 4. And 13 to 15 would be 1. So our bars, this would be 4 to 6, which means 7 is going to go here. That would mean 10 goes here, 13 goes here, and 16 goes here. In a histogram, our bars touch. Our frequency goes up to 5. Let's go ahead and label this. So we want to spread our graph out. We don't want it all like chunked from here down. So let's number every other. So 1, 2, 3, 4, 5. And we're going to title this frequency. And let's title this whole thing Maria's Vacations. So from 4 to 6 days, she did 5 times. From 7 to 9 days, she did 4 times, touching. 10 to 12 days, she also did 4 times. And her extendo vacation, 13 to 15, was only once. And that's our histogram that touches. And the last little thing is cumulative frequency, and that just adds up the total. So instead of looking and adding each of these up individually, I can quickly see that I have 20 total data. This 20 adds those things up. So how many players are less than 77 inches tall? I can quickly see right here that there's 19. You could add these up, but the cumulative frequency is your total, so that's a nice feature. Night. Hope you enjoyed.